Right, these couple of next examples will be similar to what we did with our sum and difference identities, but we're asked here obviously to use, as it says, our half angle formulas instead of our sum and difference. But we're asked to get the exact value for tangent of 15 degrees. Now I still want you to concentrate on just using 30 degrees, 45 degrees, or 60 degrees. And what you could do here to rewrite this, now since you're specifically asking the instructions to use a half angle, this is going to have to be something divided by 2. So could you do 30 degrees divided by 2 to give you 15, or 45 degrees divided by 2 to give you 15, or 60 degrees divided by 2 to give you 15? So that's how you need to look at it. Which number can you take half of that will give you 15? And of course we know that that would be 30 degrees. So in your formula, 30 degrees is your A, because I mean if you look back at your formulas, this is written as tangent of A divided by 2. So A is 30 degrees. So when you go to your formula, your half angle for tangent, again I'm just going to use the first one, I would have 1 minus cosine A, which is 30 degrees, divided by sine A, which again A is 30 degrees. So now just recall your exact values that we've used several times. Cosine 30 degrees is square root 3 over 2. And sine 30 degrees is 1/2. So I could go through, multiply all of my terms by 2. So of course down here you'll just be left with the 1. So your answer would just be 2 minus square root 3. So that would be your exact answer, or exact value. Now you can check this in your calculator very easily. Just make sure you're in degree mode. Type in tangent 15 degrees. Of course it'll give you a decimal approximation. Then type in the 2 minus square root 3. Again you'll have a decimal. Just those two decimals would need to be the same. But quick and easy to check in your calculator if you wanted to. Okay, here's this another one. This time we have cosine of 75. So in rewriting this one, again, I need to do something divided by 2. So of course, what number can you take half of that will give you 75? And that would have to be 150 degrees. Now a while ago I did say, use your 30 degrees, 45 degrees, 60 degrees when you can, which you still are, but it's going to be one of those that's going to be a reference angle to 150. So you'll see where that comes into play here in just a second. Okay, so again, this is going to be my A value. So if I go to my formula, again, I've got the plus minus in the front, which I'll explain that in just a second. But the part that's under my radical, I would have 1 plus cosine of 150 degrees divided by 2. Now, to decide the plus minus in the front is very easy here because you're asked to get the value for 75 degrees. 75 degrees is in the first quadrant, and cosine is going to be positive in the first quadrant. So that's how you can figure it out on this type of problem. Now, it's the cosine 50 degrees that we need to do a little bit of work over here to the side. Alright, so what you need to recall, of course you could draw this in standard position if you choose to do so, but your reference angle for 150 degrees is 30 degrees. And of course 150 degrees would terminate in the second quadrant. Okay. Cosine is going to be negative in the second quadrant, so that means that I can rewrite this as negative cosine 30 degrees. And then from your values, cosine 30 degrees is square root 3 over 2. So cosine 50 degrees equals negative square root 3 over 2. So that's what we can substitute back in over here. Now, I would be adding a negative, so I'm just going to change that to minus. Okay, I'm going to go through and multiply everything by 2. Okay, then you take square root of the top, and then you take square root of the bottom. So, I know especially up here, that's a different looking top number than what you're used to seeing, but that is what you would have, square root of 2 minus square root 3. But the square root of 4 would just give you a whole number of 2 on the bottom.